All right, so here we're going to do another practice problem solving for estimating a population mean. So we're going to be doing problem number 15 on page 351. And here we've got the question of whether or not garlic reduces cholesterol. So we've got an N of 49. We have 49 participants in our study. Our sample mean is 0.4. Now keep in mind that 0.4 is the net change in cholesterol. As you read in that paragraph, what they have is the individuals, first they record their cholesterol for these 49 individuals, then they consume raw garlic, then they measure the cholesterol again, and what we're working with here is the difference between those two measurements of cholesterol. So we're measuring the change or the difference between, not the raw cholesterol level. So our standard deviation for this particular sample is going to be 21, and we're being asked to construct a 98% confidence interval. Now, notice that once we're done with that confidence interval, we're going to add another step here to this problem and use that confidence interval to make some assessments about the effectiveness of garlic in reducing cholesterol. So we're going to be able to use our confidence interval here to test a hypothesis question. So that's what we're moving to, with a little bit of one more step than we did with practice problem number 1. So let's go through our steps here. Apply your flow chart. So pause the video here, pull out your flow chart, and go through and answer the following questions, looking at this to decide which analyses we need to be using, which distribution table. Are we using a Z distribution or a T distribution table? So first of all, you need to assess whether or not our sigma is known, our standard deviation for the population. Then we need to assess, is the population normally distributed, or is the N greater than 30? And based on those, you should be able to decide which distribution table you want to use. Again, this is really important to be going through these steps, especially when you get on the exam. Being able to determine which table you need to be using will be critical in getting the correct answers. So pause the video so you've got your decision about what distribution table you should be using, and then once you have that set and selected, turn it back on and let's look at it together. Okay, so we don't know our sigma here, so then we also do not know whether the population is normally distributed. We don't have any information on that. So it's unknown. So then, but we do know that our N is greater than 30, so we're going to be using a T distribution table. Now that we know we're doing our T distribution table, we know what information we need to identify. So we need to get our T critical value, and we're going to use that to calculate our margin of error, which we're then going to use to construct our confidence interval using that bottom formula there on the right-hand side. So if I'm going to be identifying my T critical value, that's the first step I've got to do now. What information do I have to have? What's the required information for assessing the T critical value? Well, I'm going to need to know my degrees of freedom, which in this case is going to be 49 minus 1. So my degrees of freedom for this problem is 48. I need to know what my alpha is going to be. So here it's going to be 1 minus 0.98, since I was given a confidence interval requirement of 98%, which means I have an alpha of 0.02. And here we need to know if it's a one-tail or a two-tail. It's not specified specifically, and since we're doing a confidence interval, that's going to give us a value on both sides, so we're going to be going with a two-tail here. So take this information, open up your book, look at your T distribution table, and find the T critical value for this problem. Now, as you're looking through your T distribution table, you may notice that you don't have a degrees of freedom specifically for 48. So in this instance, you're going to use the degrees of freedom for the value closest to that, which in this case would be 50. So if you're moving, depending upon the particular T distribution table that you're working with, as the values get larger, it may not include all of them. So you may need to make the decision of using the closest value for the degrees of freedom. So here, instead of 48, we're going to use 50 with our table due to the shape of the table. We're still going to use our alpha of 0.02. And again, make sure that you are locating this in the two-tail distribution, not the one-tail distribution. So pause the video here till you get your T critical value, write that in, and then turn the video back on and let's check it together. Okay, you should have got a T critical value of 2.403. So now we're ready to plug that into our formula for calculating the margin of error, which is going to be the T critical value times the standard deviation for that specific sample divided by the square root of the N of that sample. So pause the video here, plug in your correct numbers and do your calculation, and then when you have your margin of error, turn the video back on and let's check it together. Okay, you should have got 7.209 for your margin of error. So now we're going to take that number and plug it into the confidence interval formula below along with your mean. So again, pause the video while you plug those numbers in to get your answer, and then turn it back on and we'll check it together. All right, so you should have had 0.4 minus 7.209 for the left-hand side, and on the right-hand side, 0.4 plus 7.209. Now, we need to make our decision about our rounding rule. Remember, with the rounding rule, if it's a full data set, we move one more decimal place in the data. If it's a summary stats problem, then we use the same decimal place as the stats. So if we're looking at this problem, what type of problem do we have? Are we working with a full data set, or are we working with summary statistics that are given to us? Well, we are working with the summary statistics, so we're going to use the exact same decimal place as the statistics. So if we look at that problem over there, we can see that our mean is at 1 decimal point, so that's what we're going to round for. So pause the video here, finish your calculations, and be sure to apply the correct rounding rule, and then turn the video back on to check your answer. All right, so you should have got negative 6.8 milligrams. For your left-hand side of your confidence interval, and plus 7.6 for the right-hand side of your confidence interval. So this is what we're looking at for our confidence interval. Now we need to move that to the very next step, and we need to apply this for testing our hypothesis question of, does this confidence interval suggest that garlic is effective in reducing cholesterol? Now, to do this, we need to think critically about what we are solving for. So, if there was no difference in the cholesterol level from before I eat the garlic to after I eat the garlic, what is going to be the value of my mean net change in cholesterol? So if my cholesterol level was at 105, I ate the raw garlic, and then my cholesterol level was at 105, I subtract one from the other, I'm going to get my mean net change in cholesterol is going to be 0. So, since this confidence interval that we've calculated here does include the value of 0, it's very possible that the mean change in the cholesterol is equal to 0, which suggests that the garlic had no effect. So this is, keep in mind when we're looking at these problems, again, once you've got your calculations and doing the formulas, stepping back and thinking critically about what you're being asked to solve for in order to be able to make the final assessments of applying your results to the question you're being asked to solve. This is where we're moving towards as we move towards doing t-tests and also doing chi-squares and correlations as we prep for exam 4. So this is what we're moving towards, is being able to take this problem from the beginning all the way through, solving for your numbers, and then using those numbers and thinking about what you're solving for to be able to answer a hypothesis testing question.